All right. So I guess before we start on polymorphism, how familiar are you with like other object-oriented things like inheritance and things like that? Have you covered those?
So actually, I'm self-studying for the Comp Sci A test. I take AP Comp Sci Principles, and like my teacher, she teaches AP Comp Sci A also. So I've been doing Comp Sci A like side by side. But I take like for class I take AP Comp Sci Principles. So like on my own I've come up to like inheritance as of now, and like I know polymorphism, but I've like kind of touched it, whereas I don't know very much of it, kind of a thing.
Okay, sure. So let's go over the basics of it then, I guess.
Okay.
So polymorphism, basically the idea of it is that there's runtime and then there's compile time. So do you know the difference between the two?
Kind of, sort of, but go ahead and explain it. I'll see if I know.
Sure. Okay. So compile time. So when you say you run a program and like say the program is to just like something really simple, just like print a word, and it happens. So the results of what happened is that, do you think that happens at compile time or at runtime?
The results of what happened.
Sorry, it's phrased a little weird.
That's okay. I would think like it has to compile in order to run. So the syntax, everything like in the syntax of the code has to be right for it to actually compile. But I feel like if it needs to run, then it needs to make sense also. Like for example, if you have like inheritance, if you have you can't have like a parent, if you like, I guess, I don't know, but I'm guessing like if you have a parent object trying, or like a parent class object for a method from the child, that would throw a runtime error.
Right. So I guess taking a step back, kind of what compile time does is, I think you kind of like have the gist of it. It's kind of, it checks your code, it checks your syntax. But also like you can like tell it basically what's coming, and it'll make, and what you're gonna do about it. And the Java will tell you, when you compile Java will tell you like what you're doing is illegal or what you're doing is okay, basically.
Okay.
So I guess sorry, go ahead.
How would we differentiate that from runtime? Like so if this compile time would be like syntax stuff, what would like runtime actually be like?
So okay, so I guess the reason. So I guess you're asking like, what's the reason for a compile time and a runtime?
Yeah, like if the like compile time already catches like the syntax and like the code, then like why runtime? Yeah.
Sure. So here's an example. So you have code that like makes an array, adds a bunch of things to it, and then like randomly reads from some spots in the array, right?
Yeah.
Compile time, what it'll do is it'll check, are you creating the array the right way? Are you putting things in the array the right way? Are you using the right syntax to like try to like look up things in the array? What happens at runtime is it'll actually, but at compile time, it's not actually doing those operations. It's just making sure those look right. So at runtime, what it'll do is it'll say, it'll if there's like an example here, or I can just talk about it generally. yeah, let's find an example. I think that'll help. Well, basically, like for an array example, so you have this like array code that like creates some arrays, declares and creates some arrays, puts some values in, then it and it sets those values, and then maybe it prints some of those values. So at compile time, what it'll do is it'll check this array is doing things in the right format, and it's using since this is an integer array, it has to be inputting integers. So it'll check things like that. What actually happens at runtime is it actually executes these commands and sees if they work. So in compile time, it doesn't actually build the array and see if it sees if it works. It just kind of guesses. It says, does this look kind of right? Probably. So then you could do something like, you have something like where you use the wrong type of bracket or something, right? That would be a compile time array. But so there were errors compiling your code. But say, and this is a array of only size 5, right?
Yeah.
So if I tried to do this, it'll start running the code because this looks right, but it'll crash here because the array can only hold 5 and can only go up to index 4, and we're going up to index 5. So that's kind of the types of things.
Would that be that sorry, no, it's okay. When it goes to null, would that be a runtime error?
I think that null was this line up above. I think that was just from a prior part of the code. So if I comment this out and rerun it.
Okay.
It's printing out 99 from this array.
Yeah.
Then it's crashing here.
Okay, so when it crashes, would that be considered a compile error or a runtime error?
This one is a runtime error.
Okay, got it.
Successfully compiled.
Yeah. But why doesn't the console say runtime error? I'm just curious here. Generally it would tell us, right? It's a runtime error if it was on Dr. Java or something.
I'm not sure exactly if it always says. Maybe in Dr. Java it does. I'm not quite sure. But yeah, it depends a lot. On sometimes if you use software like Dr. Java or something else, sometimes they'll tell you more things. I'm not sure if Java naturally tells you.
Generally showed right on the console.
Yeah, that'll happen while you're compiling, not while you're running.
Okay, got it. Makes sense.
Now that we talked about that a little bit, let's get back to polymorphism. So, that's basically, so polymorphism kind of deals a little bit with that runtime versus compile time.
Okay.
So the thing is, how basically, in compile time, generally on compile time, they're keeping in general they're keeping track of what the type of each thing is, right? So in that previous example, can I not edit this? Okay, let me find one I can edit. But anyways, on that previous example, it was checking to see that the array was an array of ints.
Okay.
And it was making sure everything was coming in as an int array, as an integer. So it keeps track of what the type of each variable is. So, and in cases where so here it would be, so you have variable s. So since we declare it as a shape, the at compile time, it thinks that s is a shape every time.
Yeah.
A shape object.
Mm-hmm.
Right. Going back above, so that can come in to handy sometimes, but that can be kind of annoying sometimes, right? Because you don't always know what's coming in. So say you have code that needs to be able to deal with, in following on the shape example, you might have code that deals with rectangles, squares, ovals, everything. And they all might have a what function, but if you're storing them in an array of shapes because you want to just have one array, it becomes you wouldn't be able to just say rectangle r in shapes, right?
Yeah.
Just to double check, why wouldn't you be able to do that?
Because when we declare the array, the objects, like for example, when you have like in array in the past example, we're telling the Java that we are going to use integers, right? So similarly here, we're declaring the objects to be shape here, other than like rectangle R or like square, right?
Right. So exactly right. So these are all different shapes, but they're not just shapes. They're children of shapes.
Right.
And sometimes
okay.
like double children. So in this case, you have to, when you want to loop through all these, you have to treat them all like shapes because
they are essentially shapes, because shapes is the parent function. That's what allows the objects, even though they're not directly shapes, to be in this array without throwing an error, right?
Exactly right. So we can since they're shapes and we can't know anything else about these objects besides their shapes at compile time, right? Like in runtime, every time you loop through, you're gonna have a shape, then you'll have a rectangle, then a square, then a circle. But at compile time, all you know is that each one of these is a shape. So
okay.
What polymorphism does is basically, so each of these has a what function.
Yeah.
But so you want to be able to use like the actual, like if it's a rectangle, you want to use the rectangle what function because you want to say it's a rectangle rather than a shape. It wouldn't be very useful and since these just print out what the type is, right? Or what the name of. So it wouldn't be very useful if it just said shape every time. So you want it to print out for the what, when it says when it prints out what, you want it to print out
the what that is specialized to each shape, right?
Right. But the issue is that at compile time, it doesn't. So say you didn't have this new shape in here, and you just had rectangle, square, and circle, right?
Right.
If this shape class didn't have a what function, then the compile would throw it. Then what would happen with the compiler?
Well, it would throw an error because the rectangle, square, and circle are children of shape, even though they each have a what function, because the all those three, like I should say actually, the rectangle, square, and circle are a shape object. Like the parent function can't pull from the child function, a child method. So when we do for shape, the for loop there, for shape as to shapes, it would throw an error because the parent function of shapes can't go and grab the individual methods.
Right. And what's crucial about this kind of is that if you ran this at runtime and the shape function didn't have a shape, it would actually work because it would know it would say, okay, this isn't. I know it was declared at runtime. It'll say, I know this was declared as a shape, but this is actually, I actually know it's being created as a rectangle. So I know that this is a rectangle. Rectangles have a what function, so there's no issue. But
okay.
The compiler is the one that's throwing the issue, and you don't want this. So what happens that is like the key to polymorphism.
Wait 1 minute. I'm confused at one thing. So you're saying at runtime, if the the shapes what function, there was no what function, it would still run at one time, but the compiler would throw an error. So without it compiling, how can it run? Like, why does that work?
Exactly. You can't. Since you have to compile before you run. Like, say you had like some magic thing that compiled it without throwing you any errors. Then then you could then it would actually work. But the issue is that it would throw an issue at compiling, and so that's how that's the key to polymorphism, basically, that it lets you.
What if? Sorry.
No, go ahead.
What if, like, when we're declaring the list there, if we took out new shape, we just had new rectangle, new square, new circle, and then if, like, let's suppose the public class shape didn't have that what method on it, so in that case, it would it still throw a compile error, or would it not?
Okay, so let's we can go ahead and test that, actually. So that'll be. Oops. Wanted to do that in a new tab. So the question is, if we get rid of get rid of that. Oh wait, I think. So get rid of this and
comment that out.
Yeah. And get rid of that. So that is throwing a compile time error because at this line right here, because it's saying this is a shape, but a shape doesn't have a what function.
Okay, got it. That makes sense.
Right. So yeah, that's the key to polymorphism, basically, that even if you or at least one type, inheritance-based polymorphism. So the key to that is like declaring it as like a parent class or whatever. What or has its own functions and like characteristics. As long as at compile time it works with the declare type. At runtime, it'll actually do it based on the actual the created type.
Okay.
Mm-hmm. So you have things like
So what would be the answer to that multiple choice question for that, the one we just did, the shapes one?
Okay, so why don't you tell me?
Okay.
What do you think would happen?
What is the output from running the main method in the shape class? So it says system.out.println. Okay, so for each shape, so it'd be shape rectangle, shape rectangle, shape circle. Okay, so the first one has to be shape for sure. The second one is going to be rectangle. The third one is going to be a rectangle, shape, rectangle, rectangle, circle. D?
Let's try that. That's exactly right.
Okay, now my question here, I don't know whether this is like related to polymorphism or not. So when we extend, for example, when class rectangle extends shape. So when we do the array list for the for loop, so for new shape, it's obvious it's going to be shape is what's going to be the output. When we come to rectangle, it says print rectangle. So at this point, when it says s dot what, when it's giving the command, there are two whats. One that is specific to the rectangle, and because rectangle extends shape, the rectangle also has access to the what under the class shape. So instead of, how does it know just to print the rectangle when it extends something? Why doesn't it print rectangle and shape? Is it because if there's a method already declared underneath the child class, it doesn't even look to the parent class?
So yeah, that's a concept called like overriding, which is also good, which is part of this. So basically what overriding is if you give a child class the same like method name, like return type, or method name and like parameter list, so like taking in the same things, then the child class will be called over the parent class.
Parent class. So okay, that makes sense. Yeah.
Yeah. And there's a similar concept that people always confuse the two, but they're a bit different, is called overloading, which is when you have different methods with the same name with just different parameter lists. So So basically, if you call greet with just parentheses without any parameters, it'll do this. If you give it a string parameter, then it'll do hello plus the name or whatever. So things like that. That's another concept in Java.
That's overloading. Okay, thanks. Yeah, that makes sense.
Yeah, but getting back to polymorphism. So yeah, that's so. Do you remember? You've probably worked with like lists and array lists, right?
Yeah.
Yeah. So do you remember how you had to declare the how you had to name what the convention was for like naming array lists?
What do you mean convention?
Or
like the syntax?
Yeah, the syntax for like declaring array lists, right?
So isn't it just like array list and then the curly brackets and the name of the array list and then equals new array list and then bracket and like how much ever you want to start off, because array list you can manipulate the number of placements or like expand the size. You set like a preliminary amount of like how many slots you want.
Sorry. Right. So a lot of times people declare array lists with list here.
Yeah.
So it's because array lists and other lists are of type list, not type. So array lists and other types of lists that you don't need to know right now, like linked lists. You don't need to worry about it. But
list is actually an interface, right? So array list is kind of like branched off of list.
Right. So using that similar concept, you can have like
we can clarify with Mr. Sharp tomorrow.
Even though you're declaring it as a list, it's actually a type of array list. So
yeah,
they're implementing all the methods of list. It's basically overriding that, right?
Yeah.
Because
because it's not just declaring lists, it's declaring a new array list, right?
It's still gonna be chromosomes.
It's declaring a list, but it's initializing it as an
array list. Okay.
So yeah, that's kind of a similar concept to what we were talking about earlier, where you have
Do you kind of like? Does that kind of?
Why isn't that like called inheritance? Like instead of interface, why can't we just like is this just like a parent function? Like why is it specifically called an interface? Because I mean that's what inheritance is, right? You can
Yeah.
Oh, okay. Thanks.
create.
Bye.
So interfaces are a type of inheritance. They're a little different than normal like classes and stuff. But they actually do a very similar thing, especially to abstract classes. If you've seen them, interfaces and abstract classes actually act very similarly. An interface can actually be like defined as a special type of abstract class.
Okay.
There's slight differences, like abstract classes. I think abstract classes you can have like one. You can have like many like methods fully fleshed out, and just have one method not like left blank to be considered abstract.
Oh yeah, isn't it like abstract? It's like you can't return stuff now abstract. Like it's automatically thought to be void. Yeah. See,
you can
abstract
the methods. So sorry, what were you saying?
The methods are not initialized, right? In abstract class, that's what defines.
What do you mean not initialized?
Like the methods, they're mentioned in abstract classes, but they're not really like declared, right?
Right, exactly. So they have like the method signature, but they don't write any of the code for it.
Right. Okay. Basically. Yeah.
So, but with abstract classes, you can have basically you can take a normal class and make it abstract by just adding like one abstract method like somewhere in it, right? So most of your class can be like normal and just have one abstract method. Interfaces are all like everything has to be like abstract kind of.
Yeah.
So it's there's slight differences between the two.
Yeah, because I guess in inheritance, parent functions we can actually declare methods in the parent function. But for interface, like for example, list is an abstract class. You just state the methods, but you don't actually declare them.
Right. And then another thing about interfaces is you can implement multiple interfaces.
Okay.
And you can't be the child to like multiple classes, which is
okay. That's pretty weird, but okay.
Yeah. So it's kind of like an interface is kind of like a list of things you need to do so that people know that what you're doing is actually accomplishing something, right? So it's like for the list by implementing the list for when ArrayList implements list, that's basically telling to everyone that this is a list that can do these things. So you can have like implement multiple interfaces and say, I have all the capabilities of this interface. I have all the capabilities of this other interface. So things like it's like a slight differences, but they kind of act very similarly, abstract classes and interfaces.
Yeah, okay. Makes sense.
All right, so let's do a few more practice problems for polymorphism.
Okay. What is the output running the main method? This one, right?
Yeah.
Okay. What is the output running in the main method in the grad student class? So public class student is get food. Return this get food. student 1 equals new grad student, S1 get info, grad student extend student. Okay, so S1 get info is get food, return this, get food, pizza, I'm thinking it's gonna say pizza, but I'm not sure.
Okay, pizza. Why do you say that?
So, okay, I'll tell you how I went through it. So, class, grad student, extend student. So, when we see the main method, we're creating a new grad student. And under that, it's saying S1, which is the new grad student object, and it's saying .get info. So, get info belongs to, it has to reach to the parent class, and that says return this .get food. So, it's getting food from, because it's already in the parent class, it can't, from that method, it can't reach to the child class now, because initially under grad student class, the get food method returned taco, but because for the get info, we reach the parent class, it can't grab the method get food from the child class, so instead it grabs the method get food from the parent class itself, and you get pizza. So that was my kind of.
So the thing is, most of what you're saying, I think, was right. It just the thing when you do, like, it doesn't really work. Kind of like once you go up, you can't go back down. So when you're here, when you do get info, and you do this dot get food, this is referring to like your object, right?
Yeah.
So it's gonna do the get food that is most, which is it's gonna try to do the grad student get food first, and if that fails, then it's gonna try to go up here.
Oh, okay. So then it'd be taco.
Right.
Okay. Makes sense.
So why does it fail? Why does it not throw a compile time error, do you think?
The syntax is right. Because it extends grad student, extends student. It's able to. There's no error with s1.getInfo code. It's able to reach getInfo code from the parent class, and then it has its own method for getFood. So nothing is wrong with the syntax, or it's not. Nothing doesn't make. There's nothing that doesn't make sense.
Okay. So what if we got rid of the get food method? Would it still throw compile time? Would it still compile, or would it throw a compile time error?
I think it would still compile, because when we do get for the main method to run, it only asks to get in. Actually, hang on. No, I think it'd throw a compiler actually, because when we do get info, actually, I'm not sure.
We can check it ourselves.
We're running?
Right. So it wouldn't compile, because it doesn't just stop once it like leaves here. It's gonna keep on pursuing it. So in the compiler. So once you pass it over to get info, it's gonna say, okay, so what does this get info do? It tries to get food, and it's gonna say, this is a student. How is it gonna get food? So it needs to have this method for it to compile.
Yeah, so because when it runs, it doesn't have a problem, because it's reaching to the get food method from the grad student. But because the public string get info itself, that method is underneath the student, it's not able to compile that method itself, because there's no get food method for the student, right?
Right.
Okay.
Exactly right. All right. Let's do this one. This question.
Okay. Assume that the following declaration appears in a client program base B equals new divide. What is the result of the call B method 1? Okay, so public class base public void method 1 system dot print A method 2. So class derived extends class base, and class derived is what's running the main method. So it says B method 1. Okay, so method 1 is gonna super dot method 1, and then it says system dot out dot println C. So it would be, if it's extending method 1, it's gonna print A, and then it's going to go to method 2, and it's going to print, what does that say, 8 or B? I can't read it properly. B.
Ooh, sorry, where?
Under method 2, it's system dot out dot print. It's B, right?
Here?
Yeah, is it a B or 8? Sorry, it's not very clear.
Yeah, it's a B. Sorry.
It's okay. Okay, so first what's it going to do? It's going to go to method 1 in public class display. It's going to print A. It's going to go to method 2. It's going to print B. At that point, it's done. And then it's going to print C. I'm thinking it's... Wait, hang on 1 minute. Would it be ABC? I'm not sure, because there's 2 method 2s here, but...
So yeah, this is at runtime. So let's. So what do you think it is?
ABC?
So that's incorrect. So let's take a step back. So it does compile, but what is like the compile path? Like, what is it gonna try to do?
So
Like,
because
what is
the
compile
derived
gonna
extends...
try?
So first it's going to do method 1 for
So which
base
method
1. So when we...
this one, or it'll go here?
Well,
Okay.
because it says B dot method 1, first it's going to go to the public class, the method 1 under the derived class, and there it says it needs to go to the parent class to grab the method 1. So it's going to go to the
Wait.
public... Sorry, go ahead.
So just looking at the compiling right now, when it compiles, what will it check?
If base B, the object base, can hold the derived object.
Yeah, it's going to be declared of type base B, but it'll be created as a derived object.
Right. So if it's a derived
at compile type, does it think that it's a base, or does it think it's a derived?
Derived, right?
Remember in a previous example, here, like at compile time, it thinks it's a student, right? When it's being compiled, the first thing it'll do, it'll check the get food, and it'll go to this get food, right? Because
okay, so
at compile time, it thinks it's a student.
Base in this case.
Right. Okay.
So then, if it's a base, it compiles, but then when it says B dot method 1, because it's a derived object, does it go to the method 1 under the derived class?
Yeah, at runtime it'll go first. It'll always go to the what object it's actually created as first. It'll try to do that first.
Someone once told me that if it's on the left of the equal sign, that's compile time, like whatever objects or whatever it runs, and if it's on the right side, it's runtime. Is that an accurate?
Right, basically, yeah.
Okay. So then it's going to run a derived object for runtime. So then it's going to go to method 1 underneath under the derived class. Underneath the derived class of method 1, it says it's a super, so it has to go to the parent function. And here it says system.out.println A, so we know A is definitely printed out to the console. and then it says method 2. So the question here is now, does it go to the method 2 of the derived class or sticks to the base class?
So let's remember the student example. So it went here, and then it saw the get food function.
And
Did
it
it
went
go
down.
to the? It went down, right?
Okay. Yeah. So in this case, it's going to go down again. So method 2, it's going to be super.method 2, which technically goes back to the same thing. So it's going to print out B, and then it's going to print out D.
Right. So they'll finish with this. So where it'll go back to here.
Wait, hang on. Sorry,
So then,
we missed one thing. Under method 1 of the derived class, it says super.method 1 and then system.out.print C. So when we do super.method 1, we get A, B, D, and then now it's going to print C.
Right. That's exactly right.
Okay. Awesome.
Yeah, that one was a bit tricky.
Yeah, thank you so much.
We can do one or two more examples. It's getting close to the end, but
yeah.
So which of these will cause a compile time error of these three options?
Okay, so public class book, public string get ISBN, dictionary extends book, public string get definition string word. So for A, you have B dot get ISBN. So book A says which of the we'll do a compile error, right? So it's looking at a book B.
This code.
Okay, so it's looking at a book B.
Yeah.
If it says B dot get ISBN, that works. B dot get definition, I don't think that would work. Dictionary B dot get definition, that would work. I think the answer would be B.
Right. That's correct. So do you know about casting? Do you know what's kind of like going on here?
So it's taking a base B object and casting it as a dictionary. So when you compile it, it's acting almost like a forced dictionary object, and in that case, it's allowed to get a it's allowed to access a get definition method. So it doesn't throw a compiler because it's casted as a dictionary object.
So does casting change anything on runtime? Is it going to act like a dictionary because
during
on
runtime?
No.
When it says book B equals new dictionary, the runtime object is still a new dictionary, so it's not changing that. It's just casting the compile time. It kind of passes compiler.
What if I change this to like thesaurus and say thesaurus did similar things to dictionary, or something else, so some other thing with definitions?
Well, if you don't declare a method, or if you don't declare a class with that, then you can't cast it.
Okay, so let's say that we have another class called like public class dictionary 2 extends book, and it also has this exact same method.
Okay.
And dictionary 2, even though it's still a dictionary, but you cast it to a dictionary 2. Will that work?
No.
Okay, why not?
Because it's when we first declared the object, we said new dictionary, not dictionary 2. So it'll throw a runtime error, not a compiler error.
Okay, so let's just test that just to make sure. No, I can. Let's see if it'll let me. Sorry.
That's good.
I'm not sure if I'm going to be able to test it like this. Yeah, okay, I'll just let you know. Basically, like the compile with casting, that has like it doesn't since when you're compiling, it doesn't check the dictionary at all, except that dictionary is extends book. It doesn't like it's treating it like a book. It doesn't really care that it's actually a dictionary. So when you cast it, if you cast it as like a dictionary too, that would still work because
No,
even
yeah,
though
that would work for compile, but it would cause an issue in runtime, right?
at runtime, what would happen is that casting only stays there for compile time. Actual runtime, it runs like the actual object that it is. So it would still be a dictionary and it would work.
Okay.
So did you have any other questions? Anything else you wanted to cover?
Wait, sorry, just to clarify, for that same example for dictionary, so I understand how when it compiles, it's still going to compile fine. But when it runs, how does Java assume the casting is only for compile and not runtime? Like, for example, if we created just like the dictionary, if we did public class dictionary to extends book, and then we casted a dictionary to b, parentheses dictionary to b dot get definition. So in that case, if the new object that was created is same book B equals new dictionary, we can't, since dictionary and dictionary2 are both subclasses of parent function, dictionary can't really borrow methods from or a dictionary object cannot hold dictionary2 object. Hang on. Dictionary class cannot hold a dictionary2 object. So in that case, why wouldn't it throw a runtime error?
So kind of casting. My professor called it a shut the compiler up tool. Like it doesn't. It's what all the casting is saying is compiler pretend like this is a dictionary. It doesn't actually at runtime. It completely ignores that cast. It'll just treat it like a normal.
Okay. I got it. It's only for compile. That's the whole reason we use casting.
Right.
Okay, that makes sense. Yep, I got it.
Any other questions?
No.
Okay.
Thank you.
Yeah, thanks for coming.
Okay, bye.